On the other hand, if the box was being pulled, the figure would be something like this. This is the rough surface, the floor. Here is the box. Of course, the force of gravity, mg downwards, and the normal force acting upwards, they are very much there. Pull means the box is being pulled like that at an angle to the horizontal. You can see it. In the previous case also, we have shown the push is at an angle to horizontal, and in this case, also at an angle, you are pulling it upwards at an angle above the horizontal. Choice of coordinate system, as usual, x and y, and the frictional force coming into play in an attempt to resist the motion. And if the block or the box moves at all, then this is the acceleration of the box. So these two cases, let me name the forces. So in the very beginning, we show the forces, that is, if m is the mass of the box, mg is the force of gravity downwards, n is the normal force exerted by the floor onto the box upwards. This is the force F of pushing. This is the force F at an angle alpha to the horizontal, below the horizontal. And here again, this is the force F, same value say, or two different cases. This is the force, and it is making an angle alpha above the horizontal. The frictional force coming into play to resist the motion is to the left, leftwards in both cases. And we have our choice of coordinate system. You can easily see that F could be resolved into components if the angle is alpha. This angle is, this component is F cos alpha. And in case of push, a downward component of F is F sin alpha acting there. And in case of the pull, we see that the forward propulsive force happens to be the same F cos alpha as before, but this time the other component, F sin alpha, is acting upwards. So this is the case of pushing a box, and this is the case of pulling the box. See, if you compare the figures, we can see that, let's see and compare them. The same box is shown in both cases. The vertical forces N, mg, they match exactly same. But here we find during pushing, while the propulsive component of the force is F cos alpha, just like in case of pull, F cos alpha both cases, in case of pushing we found the component, the vertical component, F sin alpha, is acting downwards, while in case of pull, the corresponding component, F sin alpha, is acting upward. And here lies the distinction and the answer to the question whether push or pull is easier for the same block under similar circumstances. We shall explore the problem in more detail now in steps. So let us first consider the case of pushing the box. As you can see on the figure, the block's mass is of course m, and as usual we have shown the forces: gravity force mg, normal force upward n, the force of the push, that was F at an angle alpha below horizontal. F cos alpha is the component of F in the plus x direction, and F sin alpha is acting in the minus y direction, that's vertically downward. Friction coming into play in the ground, that's trying to impede, stop the motion, so that's leftwards as in the case. And acceleration might be A. So as usual, as we have drawn the figure, our job next is to write down the equations of motion, x and y motion of the block. So you go ahead and list the forces in the x direction. Sigma fx, as we say, F cos alpha, that is in plus x direction, and to oppose that in the minus x direction, the force is small f. So this must be equal to the mass of the box multiplied by acceleration, if there is any. That is my equation number 1. And then similarly we write down the equation of y motion of the box. Upward force is n, so it's positive, and then the downward forces are mg, and also we have got the F sin alpha. That component of F is acting downwards, so we write this, and since the box is not going above or below, it's not having any vertical motion, we can safely write down this must be equal to 0. So that is my equation number 2. So see this important thing, that unlike the cases dealt so far, the normal force is not coming out to be mg. Since the box is not in vertical motion, it is in balanced condition in the y direction under three forces: an upward force of n, so it's positive, and two downward forces, one being gravity force mg and other being the component of the applied push of F downwards, that is F sine alpha. So we got the equation number 2, and that gives us readily the value of n, the normal force applied onto the box upwards, is coming out to be mg plus F sine alpha. This is not mg anymore, so be careful, attentive. This is mg plus F sine alpha. So accordingly, we can write down that so long as the block or the box does not move forward, we know that is static friction, whose value might vary between 0 and Fs max being called limiting friction, and the value of Fs max, you are aware, is given by the law of static friction, that is static friction coefficient mu s multiplied by n. So when the body begins to move, now in this case, let us find this value. This is coming out to be mu s, and the value of n you can put from here, that is mg plus F sine alpha. It is not mg only, it is mg plus F sine alpha. That is the Fs max value. And when the block begins to move, then of course the friction is kinetic friction. It's a new kind of friction given by law of kinetic friction, this time mu k into n, kinetic friction coefficient, and correspondingly the value of Fk coming out to be mu k multiplied by mg plus F sine alpha. So you see that the frictional forces, be it static friction or kinetic friction, the value is coming out to be mu multiplied by mg plus F sine alpha. So that's one thing you must note carefully. So we can conclude from here, looking back at equation number 1, we can see when the body is on the verge of motion. Let me consider that case 1.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.